Okay, our next presenter, she's from originally from Hillsboro, Texas. And if you aren't familiar with the Borlaug Youth Institute, well, you need to be, because this is what Brianna participated in. Here's that one. So Brianna, she thinks she's going to graduate early in 21, but she's actually class of 22. She wants to continue on with plant breeding, get a PhD in plant breeding. So I asked her what her favorite plant was. She said pecan, not too bad. But she actually participated in the Carver Wallace Fellowship program at the University of Minnesota. So another exotic location.
Howdy, my name is BriannaCheek. I'm a sophomore plant and environmental soil science major from Hillsboro, Texas. And so I was a Wallace-Carver fellow this summer. I was in St. Paul, Minnesota at the Cereal Disease Laboratory on the University of Minnesota campus. I was there from June 9th to August 2nd. So it was beautiful 75-degree weather pretty much all summer. So we had a heat wave of 90. Yeah. And a fun fact about the campus is that there are tunnels connecting all of the buildings because it gets so cold. So you don't have to leave. You just go from like building to building underground. And so it's called the Gopher Way, which is very mascot. My project this summer, we were looking for molecular markers for Aegilops umbellulata, which is a wild relative of wheat. It has genes containing stem rust disease resistance, and so we were trying to breed those genes into wheat. And so every single day it was nice. I got to set my own schedule a little bit. If I stayed late to complete a test one day, I could kind of leave early on Friday. And so that was nice. I started off the summer with DNA extraction. I made a test set of 15 lines. It's 15 lines to test all my markers on. Started by extracting DNA from wheat, Aegilops umbellulata, and then synthetic lines, which contain both the wheat and umbellulata genomes. And so I made this test set, and the first marker that I ran was a CASP marker, which is a SNP marker, which is a single nucleotide polymorphism. So I was looking for a single nucleotide in a DNA sequence that was different between members of the same species. And so that makes it kind of like a molecular marker to help locate the genes associated with the disease resistance. And so I did this through PCR. It's basically a machine that cycles through different temperatures. And so it attaches and separates the DNA helix with primers that are searching for those single nucleotide differences. And so then we would take an image and we could identify the separation into FAM and HEX alleles. And so the different genomes would contain the different alleles. And then another type of marker I ran this summer was a cost marker. I had about 33 of these that I ran. I would do PCR on these and then gel electrophoresis. You can separate fragments of DNA by their size. And so DNA is negative, so it would run to the positive end of the machine. And so then we could look at the different fragments, their sizes in the genome. And so a 2% gel was what we would run it on. And then if we wanted to see smaller differences in the sizes, we would run it on a 4% gel and then take an image of that. And then every day would end with cleaning it up and then entering any data into a lab manual. And so a few of my results, I found out about halfway through the summer that my CASP markers, the primers ordered, were incorrect. And so they were not searching for the correct nucleotide difference. And so that was a little frustrating, but we did have one marker that ended up working. And so you can see over here that the red dots there are Aegilops umbellulata. The blue lines are the wheat, and then the green is a synthetic. So it had both the Aegilops and then the wheat. And then we had one cost marker which worked, which is this image here. And it showed polymorphism, which is when multiple bands are present for a genetic marker. And so you can kind of see that here with the two umbellulata lines. You have the polymorphism. So how I found this internship. I do not come from a farming background. I did FFA growing up. I showed goats. And so my ag teacher kind of pulled me aside and was like, hey, write this paper for me. And so I got to pick a country and then an issue that country was facing and how I would solve that issue. And so then I presented that at the Texas Youth Institute. And from there I was selected to go to the Global Youth Institute. And once there, that's when I really fell in love with plant science. And so I decided to apply for their internships in December, and then I heard back about the internship in March of 2019. And so some of my biggest challenges were just being on my own for the first time. That was what my dorm room looked like. It was very homey. And so it was just hard to be on my own for the first time and kind of in a new big city and stuff. So, but it was a good experience. It helped me to rely on myself and just, be in a new environment and meet new people. So. And I also got to explore. I got to explore the University of Minnesota campus. And then this is the Stone Arch Bridge, which is a big attraction in Minneapolis. And then my mom and sister flew up and surprised me, and we went to Minnehaha Falls. And it gets so cold up there that it freezes over in the winter. So, and then another awesome part about this internship was at the end of the summer, we all got to spend a week in Washington, D.C. All the interns from all over the country got together. And we got to meet everybody, talk about our projects, and then tour like USDA headquarters and meet some representatives and stuff. So that was a really awesome experience. And so the impact that this has kind of had on my life starts with UG99. UG99 is a devastating strain of stem rust that Norman Borlaug warned us before he passed away. And so Dr. Rouse's lab follows the USDA's motto to do right and feed everyone. We're trying to reduce losses in wheat, oat, and barley to plant diseases like UG99. And so this has helped save numerous farmers' businesses and a lot of the wheat production of Ethiopia and Pakistan. And so it was awesome to be part of science that was really making a difference. And so it really helped further my passion for plant genetics, and it was a really awesome experience.
So questions for Brianna?
So how did you find out that the timers were wrong?
Well, we weren't getting any amplification for the alleles. Like they would just, like there's this image here. Like usually you have kind of separation like this. They would all like die like here or just be like weird all over the place, and they wouldn't show data that would make sense. And so we didn't know why that was until we kind of went back to the company and they were like, oh yeah, that's not the right primers for this, for what you're looking for. So, yeah.
What was your topic that got you started?
Oh, yeah. It was sustainable agriculture in Malawi. They were like burning their fields after they had harvested, and so it was stripping the soil of all its nutrients. And so my solution was rabbits as fertilizing, like their feces as fertilizing to help kind of restore some of the nutrients and also be a source of protein for like, eating the rabbits.
Also good for rabbits.
Did you apply that in the university?
Yes, I did the program in high school and then applied my freshman year for the internship. All right, thank you.
So last years, we've actually been hosting the Borlaug Institute here on campus. And so if you're interested in participating in that and helping out with it, Daniel Harris usually asks about March, I think, is when you should be asking for help.